Welcome to the MS SQL Tips webcast, Increasing Your SQL Server Availability Options with SIOS DataKeeper Cluster Edition, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast organizer. Before we get started, if you have questions, you can submit them anytime during the webcast by entering your question in the question area in your presentation controls. We will try to answer as many of the questions as possible in the time allotted. If you have technical issues with the sound or screen quality during the webcast, use the question area to let us know. If you're not already a member of the mssqltips.com community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of the available tips, download white papers, and watch any of our archived webcasts, as well as post your SQL Server questions to be answered by our community members. Also, after today's webcast, please take some time to visit the SIOS website at us.sios.com to learn about all of their SQL Server offerings. This webcast will be recorded and archived for future playback, along with the slides, and you will receive a follow-up email with the links. So at this time, I'm going to turn things over to Alan Hurt, and he can begin the presentation.
Thanks very much, Greg. As you said, my name is Alan Hurt. Just tell you a little bit about myself if you don't know who I am. I've been working with SQL Server since about 1992. I'm currently a cluster MVP with Microsoft, although my focus is SQL Server. I've been in the high availability space for roughly well over 10 years at this point. And I am the co-founder and partner of a company called SQL HA with Ben DeBow, and we focus on mission-critical SQL Server solutions. So today I'm going to be talking about how you can use SIOS DataKeeper Cluster Edition to increase your availability options for your SQL Server deployments. There we go. So first and foremost, I need to set the stage for the context for the discussion, if you will. When I'm working with customers and we're devising solutions, there are really two things which ultimately speak to something else, which I'm going to talk about in a second. There's high availability and disaster recovery. To me, while they may use very similar technologies on the IT side of the house to achieve the end result, how you get there and the approach is very different. So when I think high availability, I think same data center, even same rack, two servers hosted, one of them goes down or has a problem, you can fairly easily, relatively speaking, switch to another server without a lot of pain and muss and fuss. With disaster recovery, on the other hand, it's a much more catastrophic effort. So if you think what happened here, with things like Hurricane Sandy, unfortunately things like 9/11, where you may have lost entire data centers, there's human impact, there's a whole bunch of other factors which makes it a much more different effort than just planning for a high availability and potentially a fairly quick switchover. Because if you're switching, for example, data centers, there's more than just your SQL servers you're bringing up. You're bringing up app servers. You're making sure that everybody can reconnect. Can you get there? There's a whole lot of other factors. Reality is that everybody needs to really think about both, but what both of these concepts ultimately speak to is something called business continuity. Because we on the IT side of the house, whether you're a DBA or a Windows person or a SAN administrator, whatever your role is, or even if you're a developer, all of what we do ties up into making sure the business stays up and running. And whether you're just architecting for high availability or doing high availability and disaster recovery, that's what you're really trying to do. It has nothing to do with technology. It has everything to do with the business. So now let's sort of take some of those concepts, move it forward, and talk about technology and where we are with SQL Server as of today and what's in the box. So we've got a few different types of things to make SQL Server availability that Microsoft provides you. And depending on what version and potentially what edition you have of SQL Server, that will influence what you could potentially deploy. So we have what's known as instance level protection, which is a failover cluster or clustering instance, depending on which documentation you read, which is abbreviated as an FCI. Now, an FCI is dependent upon a Windows Server failover cluster, or a WSFC, underneath of it. You can't cluster SQL without clustering Windows. It's a very symbiotic relationship. One of the things why I call it instance level is because it literally protects the instance. It's something you do when you install your SQL Server, and you can't do it afterwards. It's something that's an installed decision time. And everything that's in it will move as part of this mechanism. So if you have a failure on server A, and your instance fails over to node server B, also known as the node in a Windows Server failover cluster, then everything goes along with it. Jobs, logins, all your databases. Assuming it starts up correctly, pretty much outside of worrying that the application can reconnect to it, there's not much you have to do. There's also database level protection, which is pretty much what it sounds like. It protects everything within the database, but things that sit outside of the database, like instance level logins, your jobs, link servers, stuff like that, you would have to account for manually. And the features that SQL Server provides that fall under this category are database mirroring, availability groups, which is new to SQL Server 2012 and Enterprise Edition only, and log shipping. It should also be pointed out here really quickly that database mirroring is deprecated as of 2012. It doesn't mean it's gone. It's going to be probably removed within a few versions. It just means that they're not going to be enhancing it anymore. So if you're currently using database mirroring, you don't have to stop today if you're even in the middle of a 2012 migration. You just need to think about what you want to use in say, the next couple of years. And finally, we have what I like to call data level, which is the replication feature. Unfortunately, when people tend to refer to some of these other features like database mirroring or availability groups or log shipping or even clustering, they'll call it replication, and that's not correct, because replication is its own feature and has honestly been around longer than virtually any of these other features except log shipping. Now let me qualify that statement. Log shipping is just based on backup and restore, so it's technically been around since the beginning. It wasn't a formal feature until SQL Server 2000. Then with replication has actually been in the product since 4.2.1a. It comes over from the Sybase lineage. And one of the things why I call it data level protection is that unlike database level protection, which is geared towards getting everything inside the database over at a transactional level and you know, having essentially a full copy of your database elsewhere, replication is something where you have to define what you want to be elsewhere. It has the same problems as database level, where you got to worry about logins and all this other stuff. But with replication, you also have to define what it is you want to go over. Now, it's also the only feature that could potentially be used for availability where you could only have a subset of data on the other side. So that's one of the advantages to replication, but I will tell you it is not the technology or feature I would ever lead with, and it's not one I tend to use in an availability situation. I tend to use it more for things like reporting and other things like that. But it can play a role in business continuity, absolutely. There are also what I like to call external solutions or third-party solutions. So there are third-party products like the SIOS stuff I'm going to talk to you about today and how that could influence things. If your SQL servers are hosted as virtual machines under a hypervisor, and that could be VMware, it could be Microsoft's Hyper-V, it could be Xen, it doesn't really matter. There are native high availability features within each of those hypervisors that you could potentially use, but realize that your high availability strategy is largely now out of the hands of the DBA and is almost squarely in the palm of the VM administrators or people who are responsible for that. So that's stuff that would need to be discussed and how that impacts your overall strategy. Finally, to complement a lot of these technologies would be a storage-based, which also kind of SIOS factors in here as well, where you're doing some sort of mirroring of storage, or you're making sure that you can move your storage from A to B. Now, this is what I would call block level, because it's working underneath the covers at the disk level, essentially, to get things from A to B. It has nothing to do with SQL Server, and it essentially kind of has nothing to do with Windows. You're taking things at a low level, the basic zeros and ones of what you're storing on disk, and moving them to another place. Okay. A thing I need to qualify here, because we're going to be talking today a lot about storage, is how a clustered instance of SQL Server uses storage. Now, I will say that I am a cluster MVP. I've written a ton of stuff on clustering SQL Server. I did the 2000 and 2005 white papers for Microsoft. I've done quite a few books. I'm working on my current book, which is called Mission Critical SQL Server, which will be out in hopefully a couple months. But I will tell you that FCIs is arguably one of the most popular options for making SQL Server available, which is great. But what people don't always understand is everything that comes along with it, especially how you configure storage. Now, traditionally, we have a shared disk solution. And what do I mean by shared disk? So basically, you present storage from your, say, your SAN to the nodes of the cluster, but it's called what Microsoft likes to call shared nothing. And the reason for that is that a single node who owns the particular disk resources can only see that storage. It's not load balanced. While any of the nodes in the cluster could potentially own the storage and use the storage, only one can do it at a time, and that's why it's called shared nothing. But it's still shared storage, meaning, like I said, you're having SAN, so depending on your situation, that could potentially be very expensive disk. SANs are generally shared solutions, so it's not just SQL Server being hosted. You've got Exchange, you've got file servers, you've got any number of other things on that same storage unit, so it's not dedicated to SQL Server. SQL Server 2012 expanded your options, and you can now use a server message block, or SMB 3.0 share. In essence, you can use a file share. So it's not quite NAS or network attached storage. It's basically, you would do like whack server name / share name. Just like sometimes in your companies you may have, let's say, a shared installation point. That's a share. Same concept. You can now put your SQL Server data and log files and backups all in an SMB share, fully supported by clustering. That means that now, for example, you need to make sure that your file share is highly available and that your networking isn't going to interfere with your IOs. So it just shifts, what you need to architect and what you need to account for. Another thing that they brought into SQL Server 2012, by the way, SMB is also in 2014. I didn't want to imply that it's not. Apologize for that on the slide. So another thing that they brought into SQL Server 2012 carried over into 2014 is that you can have a local TempDB. Now, you'll see in a moment where this has played in for a little while with one of the technologies that I'm going to talk about. But the reason for this is, as I was talking a few moments ago, shared disk can be a very expensive resource if you need high throughput, and it's a big shared resource. So something like TempDB, where you may use it heavily, that's going to get thrashed all the time, you may want a better option. So a lot of people have started using dedicated storage within servers, even outside of clustering, just in standalone implementations to speed up TempDB. And one of the most popular options is to use some storage cards from a company known as Fusion.io. And they're pretty well established in the community. If you talk to a lot of people with high-end SQL servers, you'll see they use Fusion.io stuff. So basically, you could do, in this example, you could throw Fusion.io cards in your local nodes for your cluster, configure TempDB locally. All your user and system databases besides TempDB, as well as your backups, are still on shared storage, or like say on an SMB share. But it means that you're not using expensive SAN disks to get the IOPS that you need. Another option coming in SQL Server 2014, which I'm going to talk about a little bit in my pre-con for PASS in a few weeks, is clustered shared volumes, or CSVs. And CSVs were originally designed just for Hyper-V VMs, but starting in SQL Server 2014, you can also use it to store your SQL Server databases. It is another form of shared disk, but architected in a very different way and has a lot of benefits. Excuse me. So a little preview for you there of what's coming in 2014. I do want to point out here, as I sort of mentioned, no matter what, all of the system DBs, user DBs, and backups outside of temp DB are generally, not generally, you can't put on local disk. It's got to be on one of these solutions. So this is sort of plays into the overall architecture. Now, what does this look like? Okay. I don't know where I got that message for webcams, but no, I'm not broadcasting a webcam. A typical cluster looks something like this. So we've got, here for example, we've got a 2-node Windows Server failover cluster. You can have as many as OS supported, depending on the addition of SQL Server. You generally have redundant networking. With Windows Server 2008, they did away with the concept of really public and private, although people still kind of use them that way. All Windows cares about is that you have multiple ways for the cluster to ensure that the nodes can talk to each other. So I have the networks are labeled external traffic, and then network for Windows Server failover cluster redundancy. You'll notice there that I've got my shared storage with a solid line coming from node 1 and the dotted line coming from node 2. That indicates that shared nothing thing that I talked about. And because only one node can own a particular, say, LUN that's presented to the cluster. Now, how does DataKeeper play into all of this? So first of all, let me give you a little background on DataKeeper. DataKeeper's been around for a while. I think the company's been around since about 1999, so they're not new to the space. They've been playing with, not playing, I should say. They've been working with the Microsoft space for actually quite a long time. Actually, one of their employees is a fellow cluster MVP, so they're not new to this space, right? They've been playing in this arena for a while, but how does it work? So traditionally, when we think of storage mirroring, we think of hardware-based. So if you've got an EMC SAN or an HP or Dell Compellent, whatever you've got, they've got some native utilities and tools and to mirror at a hardware level that's baked into their stuff. That stuff is great. It all works fine, but sometimes those options can be expensive or not exactly as flexible as you want, whatever it winds up being. DataKeeper is a software-based solution that essentially does the same thing. So what DataKeeper can do, and specifically DataKeeper Cluster Edition, is it can provide block-level replication to create mirrors of disks between cluster nodes. So you can create a cluster that doesn't need shared storage. I'm going to demo this, but basically what this is, it's a partnered solution with Fusion.io. So we're taking a technology we're familiar with in the SQL space in Fusion.io and using it in machines where it might have just been, say, used for TempDB or high I/O stuff. Now we're extending it by putting DataKeeper on top of it, where we can have highly performing as well as highly available clusters without the need for shared storage. And you don't need to go to your SAN admins all the time and ask them for new space and all this other stuff. It's essentially a locally controlled solution, but it's still a cluster. Now, the thing I do want to point out here, though, is that the example here, you've got sort of the same two networks I talked about before, but you're going to have an additional network that you dedicated for the disk traffic. And that's highly recommended in these types of scenarios. And the same would be true if you're using something like iSCSI in a shared storage environment. You shouldn't use either of the cluster networks, whether it's the externally facing or the internally facing or redundant ones, even if it happens to be externally facing, because you don't want to jam up regular traffic with I/O traffic. And we've got there, essentially, I've got the picture of what the software doing the replication between the cards there in the local nodes. So what are the benefits of this? First of all, even though the picture I showed before is a two-node cluster, you can have more than two nodes. It's just easier for display purposes to show two nodes. One of the really nice things, and I'm going to show you a demo of this in a couple of minutes, is that it totally integrates with Windows failover clustering and with SQL Server. So the screen you see there is if you're running the GUI install for a clustered instance of SQL Server, you will see that screen when it prompts you to select what disk. You see there that that's just the disk that's presented to the cluster from DataKeeper. So there's nothing outside of implementing DataKeeper Cluster Edition. There's nothing new you need to learn here, really. It integrates with features and a solution in Windows failover clustering that hopefully most of you are familiar with or have been considering. So there's nothing, and part of that too, by the way, is that SIOS and Microsoft, if you have an issue, they have a really great working relationship, so they can help you diagnose your problem. It's not like I've heard horror stories from customers where they've implemented a solution and that particular vendor doesn't have a close relationship with Microsoft. So you've got to go through, say, calling them, and then they say, well, it's Microsoft, and you call Microsoft, and they say it's the vendor, and then we get into the finger-pointing game. You're not going to find that in a solution like this, and especially since something like Fusion IO is involved, because Fusion IO also has a great relationship with Microsoft as well as SIOS. So if you run into issues with this type of solution, they're going to be able to help you with it, and on top of it, that means it's also essentially fully supported, the entire stack. You're not going to be putting your deployments at risk because you're deploying something that's so bleeding edge and cutting edge that nobody supports it or knows about it. Everybody's aware of it, and you'll be able to get the help you need. And as I mentioned on the previous page, probably the biggest benefit to a lot of people is that the storage is local to the nodes. It's not shared, which means you can architect your solutions a bit differently than you would in a traditional cluster. Now, I want to put the caveat out there and say this solution may not be for everyone. It may fit a great deal of yours who are out there in webland needs, but it may not be right for everyone. But for those who need it, this gives you great availability along with performance that you may not be able to get out of a traditional solution. Okay, so let's see that demo that I was actually talking about. First and foremost, what I want to show you is my traditional cluster that I have here in my lab. It happens to be Windows Server 2008. It doesn't matter. DataKeeper and clustering, you can do 2012 or Windows Server 2012 R2 or what. Don't worry about version of Windows here because DataKeeper will work with essentially all the ones that you're going to need to deploy. But this is a traditional one with shared disk. So I've got my cluster here, my Windows Server failover cluster, and my cursor, there it is, called Steely Dan. I've got two nodes. I've got Becker and Fagan. And I've got two SQL Server instances, Asia and Pretzel Logic. Okay. Now, the reason I have two here is if I look at my storage, I've got my witness for my quorum because I've only got two nodes, so I need some sort of witness. And in this case, I'm using a shared disk. You can also use a file share witness, which will come up a little bit later when I show you some other architectures. And you'll notice that the storage here is dedicated. So for the Asia instance, I've got this LUN, and for the Pretzel Logic instance, I've got this one. Now what this means, if we go look here, all these resources are dedicated to this particular SQL Server instance. And just to show you, I'm connected to these instances here. These are very real, very live. And it's mixed, by the way, here. So I've got SQL Server 2008 R2 as well as SQL Server 2012. So I've got a mixed cluster here. Oh, that's not what I wanted to do. All right. Now, one thing I want to point out to you is that besides the fact that storage is dedicated to each instance, and it would be the same if you're implementing SIOS DataKeeper, by the way, this is a fundamental cluster mechanism in the way that it works. It's not going to change the way clustering works. A misconception that I get that people don't always understand is if I've got a physical LUN that's presented to my servers, but you partition up logically into two drives like this, to a Windows Server failover cluster, it's presented as one disk. So Pretzel Logic could never use E or F. It's only ever these two disks are only presented to Asia. So there's no real benefit to logically, or I should say there's very little benefit in a traditional shared disk environment to logically partitioning a single LUN and presenting it to a cluster. I'm not going to do failover here because, again, this is what you know. This is what you implement today. It all just works. No problems. Like I said, this is a multi-instance SQL Server failover cluster. Now let's look at the SIOS solution. First and foremost, there we go. Okay, first and foremost, let me bring up Failover Cluster Manager. So you'll see here, for all intents and purposes, this looks exactly the same. If I look at my storage, it looks exactly the same. Remember, I showed you this slide. Bring it up real quick. When you install a SQL Server, it appears just like it would as if it's a traditional, normal, everyday shared disk. Okay, let me get back to this. So there's nothing here that gives the indication that you've got nothing but traditional shared storage underneath the covers. However, let's look at a couple things. So if I look at this, I see, here's my first node. Here's my Fusion I/O card. It's split up into three logical disks, M, T, and S. M has the bitmaps, or basically what DataKeeper needs to keep the mirroring in sync. Now, if I go look at the Fusion I/O stuff here, you can see, for example, where'd it go? Settings. Not what I wanted. There, sorry, that's what I wanted. I really am using a Fusion I/O card. It's M, T, and S. Now, if I go to the other node, and this is something I didn't show you in the other demo. If I have time, I'll go back and show you. But basically, when the storage is only presented to one node, it never shows up on the other one. But if I look at things here, I've got, let me just make this bigger. Again, local storage, same thing. M, S, and T. Actually, M and T, because S right now is technically owned by the other one, technically because of the cluster, right? So, but bottom line here, again, we see this here. Again, this is local disk in a card in the node, right? But it's essentially shared just as it would be traditionally with a cluster in the way that you would have traditional shared storage. So now what I'm going to do you'll see that I'm currently owned by the SIOS 1 node. Okay. By the way, let me show you how this is done in DataKeeper before I show you the SQL Server portion. You create what's known as a job to mirror the disks. It's really that simple. Everything's healthy. It's mirroring. So again, nothing really weird here. It's very simple to set up. So, and this is a utility you'd use to see your status. There's some command line as well, but I'm not going to be demoing command line today. Now, just to show you that I'm also owned by SIOS 1, I'm going to execute this. You'll see I'm the current owner of SIOS 1. And if I select stuff from this table, you know, I've got A and B, I'll insert the value of C. So I've got A, B, and C. Great. Now what I'm going to do is manually fail over this instance to SIOS 2. Going offline and coming back online, coming up in dependency order. So the cluster, again, here, is, as we're watching failover, it's acting just as if any old normal clustered instance of SQL Server does. Came online, beautiful. And I could go issue this query, and it just had to reconnect, and you'll see that I have A, B, and C. It's because it's mirroring the disk properly. You don't have to worry about data not getting over. It's block level protection. I'll insert D, and you'll see here, by the way, I'm running on SIOS 2. Now I just inserted D, and now what I'm going to do is I'm going to flip back, and you'll see that, again, it works both ways. Now, let me say one thing about block level. Block level is not transactional. So as a database person, I care about transactions, right? However, SQL Server being what it is and the way failover clustering works, if something didn't get committed properly or say the transaction is incomplete, part of the mechanism of clustering when the instance comes online is to make sure that everything is transactionally consistent. So you won't have incomplete transactions if something didn't complete from an I/O standpoint. SQL Server is going to function properly. So now I'm going to go back here. I'll be slightly disconnected, and it'll bark at me for a second, and you'll see A, B, C, and D. And again, just to prove to you, even though you saw it there, I'm running on SIOS 1. So again, this is just showing you that with all local storage using SIOS DataKeeper Cluster Edition and Fusion IO cards, it acts, behaves, looks, feels just as it would as if you were using shared storage. It's mirroring between them. So if you fail over to another node in your cluster, whether it's the second, third, fourth, fifth, eighth, 16th, doesn't matter, and you fail it back, all that data is going to be there because the mirroring mechanisms take care of that for you. So I hope this makes you at least understand what's going on behind the scenes and how it manifests itself in SQL Server. Okay, let's get back to the deck here. Now let's talk about what DataKeeper Cluster Edition brings to the party for disaster recovery. There are three main headings that we could look at when it comes to here. A traditionally geographically dispersed Windows failover cluster. You can implement this as an entire Amazon EC2 solution, or what's even cooler now with the rise of the cloud, so to speak, is you can have a hybrid on-premise EC2. Now I say EC2, they will work with other clouds, but EC2 is, they're an Amazon partner, so that's why I'm highlighting the EC2 thing here. The key thing with any kind of disaster recovery, especially with something like this where you're going to be spanning disks and connectivity just for your cluster and things like that, whether it's all on the cloud or hybrid solutions, or even a plain old geographically dispersed cluster that's going to have, say, maybe multiple. You've got to worry about your networking situation, because if you don't, then this thing is not going to work. So I have a sample shortened link there that you can look at later of how Amazon approaches this solution. So you can have a look at that at another time. Okay, so what does this look like? You notice it's just slightly different than the other picture. Basically, we have two sites with the same DataKeeper stuff, but instead of, say, in the traditional world, where we would have hardware-based storage mirroring, you're using DataKeeper. It's really just that simple. And you don't need to, say, do the DataKeeper FCI solution that I just showed you, although that can work as well over sites. You can use DataKeeper in a traditional just mirroring of disk solution, right? So even if you're not, and SIOS has other editions that support that as well, so even if you're not going to use DataKeeper Cluster Edition, SIOS has other editions if you just do traditional disk mirrors using this software technology. So you can just mirror disk, and in those cases, what a lot of people do is they will have their disaster recovery site essentially down, or at least their instances turned off. And Windows may be on for the disk mirroring, but they only power the SQL Server instances on in the DR site when they need to bring them on. So here, essentially, like I said, there are two variations. The full FCI implementation where it's fully integrated, actually three variations. You're mirroring disk at a plain old storage level, or you're doing the complete FCI, SIOS, Fusion IO scenario. So you've got three options here with a geographically dispersed FCI and Windows Server failover cluster. Now, looking up to the cloud, let me explain a little bit to you how Amazon works. When you sign up for Amazon, you can put your essentially your virtual machines that they host up in what's known as a region. So, for example, like an East region or a West region, say here in the United States, right? And within each region, they have something called availability zones. So within a particular region, you can now create these similar types of solutions, granted not the Fusion IO part, but you can create, say, a Windows Server failover cluster, or even if it's just standalone SQL servers, right? You can use DataKeeper to make your disks that have the SQL Server databases available. So in this case, for example, let's say you have two standalone instances of SQL Server. You could just mirror the disks, have SQL Server down on your server in Zone B, and just have it mirroring the disk, and then power it on. So again, traditional things that we've done, just mapping them to the cloud. Now here, you can actually deploy a Windows Server Failover Cluster FCI solution up in EC2, where you would have, say, your file share witness. So you notice in my examples when I showed you clustering, I used a disk-based witness. But because there's no concept of shared disk here, you need to have, in this case where we've got two nodes, something for quorum. So we have a file share witness that will stick in Availability Zone B. And we've got our nodes split over Availability Node A and C. So we've got essentially separation here for your three roles. But we're doing the FCI solution using DataKeeper. So very cool stuff. Now you can even extend that out and span regions, and you can essentially set up a geographically dispersed cluster. Now you may or may not need a file share witness depending on your cluster configuration and number of nodes. When we've had the two, we will need something, but in the case of here with three, you may not, depending on if you set up boats or not. And that's outside the scope of this particular webinar. I'm not going to get into how to configure that stuff because quorum isn't the focus here. But just know that you can span availability zones, and just like the traditional one, you can go beyond two servers. You're not limited here in what you can do. So After this, I'm going to open up the floor and look at questions, because clearly I haven't looked at questions at all. But to summarize, you're basically taking solutions that you know, which are mirroring of disks at the hardware level or FCIs and WSFCs, and marrying them to new technologies that you may not have used, or you may use but don't use in this way. Because SIOS and Fusion.io and Microsoft have a great relationship, you're not dealing with a solution here that would be questionable to deploy and where you'd have to worry about supportability. I wouldn't be talking about this if I didn't think that this is some rogue solution, because I do clustering all the time. One of the things that I espouse when I walk into a client as a consultant is that any solution I put in has to be supportable and manageable. And as you saw, there's nothing really new you need to learn. There's one piece of management for Fusion.io, and there's a piece of management for DataKeeper. But beyond that, you're using everything and all the skills and knowledge that you have already with, say, clustering and both the Windows and SQL Server level, and just applying it slightly differently. The biggest part about this local solution, especially with Fusion.io, is that this can help you, especially if you're I/O challenged, because not only are you going to get the availability you need, but you're going to also get the performance that you need. And it'll also help you, actually, which I didn't really talk about or show, so you can span your on-premise solutions. So let's say you have a local cluster, and you want to have disaster recovery in the cloud because you found it to be cost-effective. Well, you can use DataKeeper to mirror your disks up to the cloud and have a server up there ready to go that you could flip to. So it's a pretty versatile utility and tool that you can deploy that, you know, opens up some of your options. Now, as I said earlier, is this going to be the perfect solution for everyone? It may not be, but it's certainly something that I would consider if I was looking, you know, at overall availability solutions, and I felt that maybe some of the stuff built into the box maybe didn't fit my needs, especially in having the flexibility to have local storage in my nodes. And with that, we've got a few minutes for questions. I wanted to make sure that we had some time. So I'm going to go look at the questions. If you have anything, let us know. Thanks for taking the time today, and we'll see you down the road. We'll be answering questions now. Okay. Let's see here if some questions haven't been answered. It's really hard to see in this view. I also invite at this point, by the way, the SIOS folks to unmute themselves if they would like to answer some of these questions. Okay, is there, hopefully, I can't really.
Sure, Alan. This is Tony Tamarca. There's I think we've answered a lot of the questions via the chat. There's one outstanding question about, are there monitoring tools available for DataKeeper and can it be integrated with SCOM? So DataKeeper provides its own set of perfmon counters. You can take a look at things like mirror state, and there's lots of different counters that we provide so you can monitor various aspects of data replication. And as far as events, if mirrors change states and they go from pause to resyncing to mirroring, or they switch over, things to that effect, all those events get logged into the event viewer as well. So you can scrape the event viewer to see what's going on or to be notified when certain things happen.
So I see the question there. So our organization is considering SQL Server 2012 availability groups. By the way, the terminology is AG, not DAG. It's AG versus DataKeeper. What are the pros and cons of each? So think back to what I was talking about earlier in the presentation, with availability groups, you're getting database level protection, and it's transactional based, versus DataKeeper, which is disk level, and which means block level. So they're very different things in essence, right? So you need to think about when you're your availability solutions, be they high availability or disaster recovery or both, what are you trying to protect? What's going to be the fastest way to get you to there from here? Or what is the best way for your organization? Sometimes it's a combination of things. But availability groups, again, that's a built-in feature of SQL, and it is database level protection. So if you're very worried about transactional, then that may be a better option for you in some cases. Now, as you saw, granted I wasn't throwing a whole heck of a lot of load there. I was doing a single insert statement. The DataKeeper solution, as long as your network is functioning properly, you shouldn't really have any loss here, right? Because you're essentially deploying a cluster solution. Now, the other thing that I really didn't talk about here as well is remember that because this is local storage, you're essentially removing the one single point of failure in a traditional clustered implementation is that you've got one copy of data. With DataKeeper, you've got two copies of the data on the nodes. So just figured I'd bring that out because I did forget to mention that earlier. I'm not sure if you guys answered that other question, how does DataKeeper deal with extended secondary outages? But Tony or one of you guys can answer that if it hasn't been answered already.
Yeah, no problem. So great question. And that's exactly, Alan mentioned before that there's a bitmap file technology that's associated with the mirror. And the bitmap file is a statically sized persistent file. Think of it like an array or a pointer where it's each bit in the file maps to a block on the volume that you're mirroring, and we're tracking which blocks are in sync and which blocks are out of sync. So if you have a scenario where you have some extended outage of your secondary system, also what we call the target side of the mirror, that's exactly where this bitmap file comes into play, and we're tracking exactly which blocks have been modified during that time period and which ones haven't. So when the target system comes back online, the mirror will automatically resume itself and a resync takes place, and it's a partial resync, so we copy over that delta. So the bitmap file tracks exactly what data is in sync, what data is out of sync, and we can get you caught up much quicker this way. Great question.
Yeah, and let me also say there that could be a potential advantage in a disaster recovery scenario where you still have access to one that has, say, data, and you don't have to do like a full resync. So let's say you've got a 5 terabyte database, and the delta is 200 meg or something, right? You're resyncing 200 meg instead of having to reseed an entire database of 5 terabytes. That could be a potential game changer for some folks, especially in larger shops. For certain solutions, right? It may not be a fit everywhere, but for those solutions where you need that kind of turnaround, it may be the perfect fit. I do see the question there, what I'm sure is answered, but I just want to reiterate. The question is, are you replicating at the file system block level or replicating at more the SQL transaction database page level? It's file system block level. And that's why I made the distinction earlier of talking about transactional versus block level. So are there any other questions? So we've got a couple of minutes here. Okay, here we go. For async modes, how often is replication performed? Is right folding performed? The SIOS guys answer that.
Sure. Thanks, Alan. So with async, well,
hey, Tony, you might want to turn off your speaker.
Yeah, I think someone else has got theirs unmuted. Yeah, so in both synchronous and asynchronous replication modes, it is real-time replication. So we're not doing some type of batch or some periodic, every 5, 10, 20 minutes. It's continuous replication with both modes. So even in an async mirror, the write comes down on the source side of the mirror. It gets committed to the local storage, and then a copy of that gets placed in an async queue to be transmitted over in real time. So again, it's continuous real-time replication. We're not doing any type of stopping and starting to send it over on a periodic basis.
And just in case anybody else had the question, as Greg mentioned, they are recording this webinar, and it will be available after the fact.
All right, doesn't look like there's any other questions, so I guess we can just wrap things up a little bit early. So again, as Alan said, today's webcast was recorded, so you'll receive a follow-up email with links to the webcast, as well as we'll try to get a copy of the slides so you can download as well. I want to thank Alan for all the great information that he shared today, and also want to thank SIOS for sponsoring today's webcast.
We have actually got a couple of latecomers to the questions.
Okay,
so
take it away.
I'll let SIOS answer the first one, the resync, but let me quickly answer the second one. Does SIOS DataKeeper support standalone servers? As I mentioned, yeah, that was one of the scenarios that I talked about where you could have, say, the 2 standalone servers set up, or more than 2, where you would, say, have your standby server powered down and just mirror your disks, and then just bring the instance up. So yeah, it will work with a standalone. I was highlighting the FCI solution mainly today, but it can work in a standalone server scenario. Do you need 2 copies of DataKeeper in each? Okay, so active is wrong terminology, folks. Go to my blog, SQLHA.com. You can search for active. But you do install the DataKeeper software on each node of your cluster. So it doesn't matter how many instances of SQL you have on your cluster. You don't need a copy of DataKeeper per instance of SQL, but you need a copy of the DataKeeper software per node of the Windows failover cluster. It's sure. I'll type it in a second while SIOS answers the question. Are there any instances where a full resync would be needed?
Sure. Okay. Great question. So basically, anytime you have a switchover or a failover, it's going to be a partial resync. The time where you're going to have to do a full resync is essentially if you lose a disk. You've got 2 machines, node A, node B, and you're replicating from A to B. And let's say the drive that is acting as the target completely fails and you need to put in a brand new disk. In that type of a scenario, you would have to do a full resync of the data. But pretty much aside from that, anytime you're doing a cluster switchover or a failover, that's why we implemented that bitmap file, that bitmap technology to exactly to prevent you from getting into that full resync scenario. It's a great question. Pretty much
another question for you, Tony. I don't know if you could answer this or you want to defer this. There's a licensing question there.
Yeah, sure thing. So as you mentioned before, Alan, DataKeeper is licensed on a per node basis. It's a perpetual license. There's 20% annual support and maintenance, which gives you access to our technical support team via phone, web, and email. It also entitles you to updates to the software as well. For specific information, I would just suggest you reach out to sales@us.sios.com if you want specific pricing information or quotes or things of that nature. But just to summarize, it's per server with perpetual license and 20% annual support and maintenance.
And it looks like this is another question that snuck in, and unless anything else comes, another couple ones. Okay, so so first of all, is it possible to configure mirroring on a database that's already configured for always on? So first, let me again just correct some terminology. There is no feature called always on. There's always on is a marketing thing that covers both clustered instances and availability groups. So I assume you're talking about availability groups. And again, I also have a blog on that terminology, blog post at the link that I sent out. But yes, you can configure this block level mirroring where you would have, say, an availability group primary server. So you could create a disaster recovery solution on top of what you would get on top of availability groups. So you can combine these solutions. So it is possible. You'd have to obviously work through the scenario of where you'd want to fail over and how that would work, and how you want each one to be presented, but I don't see any reason why you couldn't combine them. Another question, any tips for avoiding dead brain solutions, i.e. both servers think the other one is down? So I think what you mean here is split brain, and that is a failover clustering thing that has to deal with quorum, and unfortunately in the 5 minutes we have, this is a much bigger discussion. But bottom line is that split brain scenario generally only happens when you lose network connectivity. So a really quick tip, as I said, is going to be making sure that your networking is rock solid and that you're not going to have any issues there. And that's the quickest answer I can give you with only like 3 minutes left, because that could be like a half a day on its own of going through the wheres and whys of this. How does Fusion DataKeeper work with Fusion Ion Data Accelerator? Can you answer that one, Tony?
Yeah, sure thing. So again, DataKeeper can work with any type of storage, any block storage. And Fusion IO's Ion Data Accelerator is basically it's Fusion IO cards that are placed into a server that acts as a shared storage device, and it's presented to a server via fiber channel or iSCSI. So to the Windows server that is connected to it, it just shows up under Windows Disk Management. Looks like a hard drive. So you could use that as the source or the target side of a mirror. Again, DataKeeper will work with any type of block storage that you want to connect to the server involved.
So I see there's a question here that I'll answer a little bit. Tony, you might want to clarify. If I want to replicate from SQL Express to SQL Standard Edition, is that scenario supported? Remember here, you're replicating at a block level or a disk level, so in theory it could work, but essentially when you're doing something like this, your target, unless you're in like an FCI solution, your target server is essentially going to be down, and you're only ever going to bring it up if you have it. If you need this for like reporting and stuff like that, in that scenario I would recommend doing traditional SQL Server methods. So if that's what you're looking to do, use SQL Server. But if you're looking to set up something where you just want to have the databases that you have in Express over and move at a block level, in theory it should work. Do you have anything to add to that, Tony?
No, I think you've covered it.
Okay, and can you have local Fusion IO cards as mirrored and then add DataKeeper to replicate it to another server with identical mirrored Fusion IO cards? I don't know the answer to that.
Yeah, the answer to that is yes. Again, you can configure the physical storage however you like. And the way I'm reading this question is, say you have 2 servers, each server has 2 Fusion IO cards. You can take those 2 Fusion IO cards in each server and do a local software RAID just inside the box. You go into Windows Disk Management, you would mirror the Fusion cards locally inside the box, and when you mirror them locally, it gets presented as a single drive letter as an example, and then that could be used as the source of the target. So yeah, the physical disk setup, you can set it up however you like. You could do a local mirror of the drives. You could stripe them. However you want to configure that is supported.
Well, it looks like we're just about at time. I'll turn it back over to Greg. It looks like we weren't getting a lot of questions. So thanks, everyone, for your time. Hope this was informative. The webcast will be up there shortly, and turning it back over to Greg.
Thanks, Alan. And thanks again for the presentation. And thanks, everybody, for all those great questions. Also, thank you, SIOS, for sponsoring today's webcast. And just ask that as you exit the webcast today, just take a couple minutes and fill out the survey. It helps with today's webcast as well as future webcasts. Once again, the webcast was recorded. You'll get a follow-up email that'll have links to the recording as well as the slide deck. Thanks for attending, and hope you all have a great day.